and welcome. Today we're going to be continuing the Advent of Code optimization. I don't quite want to call it like a series, but it's effectively a series at this point. That we've done a couple of times where we basically take an Advent of Code problem and we solve it in Rust, and then try to optimize it as best as we can, and within a certain time period, so we don't spend like hours on it. But yeah, so I think we did day 12 last. Probably should pull this up too. And let's see where we go. Yeah, so let me set up for day, what is this, 13. So we'll copy that. And let's add the day to the cargo tunnel. 13, bam. Cool. And then let's implement that. So day 13, let's read this. In years past, the holiday feast with your family hasn't gone so well. Not everyone gets along. This year you resolve will be different. You're going to find the optimal seating arrangement, oh god, and avoid all those awkward conversations. You start by writing up a list of everyone invited and the amount their happiness would increase or decrease if they were to find themselves sitting next to each other person. You have a circular table that will be just big enough to fit everyone comfortably, so each person will have exactly 2 neighbors. So this is a dynamic programming problem, which I'm not exactly fantastic at, so we'll see. For example, suppose you have only 4 attendees planned, and you calculate their potential happiness as follows. Let me grab the input file. And let me grab the example. Okay, for example, suppose you only have 4 attendees planned, and you calculate their potential happiness as follows. Okay, so this person plus 54 for Bob, this person, or Alice, minus 79 for Carol, okay. Then if you seat Alice next to David, Alice would lose 2 happiness points. Because David talks too much, of course. But David would gain 46 happiness units. Because sitting next to Alice, okay. For a total change of 44. Yeah, that makes sense. If you continue around the table, you could then seat Bob next to Alice. Okay. Finally see Carol. Yeah, whatever. Continue this. So it's interesting here. It's basically start off with somebody, then find what the, between these 3 pairs, what the highest net happiness is. So like sitting next to Bob gains 54 happiness for Alice, but then you end up with like negative, what is this number? Like 20 something. Negative 29. I can't math right now. Oh wait, no, this is gain. So never mind. This isn't like a large amount of, fuck, I'm wrong. No, because yeah, that's gain. So if Alice and Bob sit next to each other, then the happiness goes to like 130 already. So it's not just like greedy approach. I mean, to be honest, how many people do we have in here? So we've got 1, 2, 3, 4, 5, 6, 7. So we've got 8 people. I mean, just like actually just going through every solution doesn't seem to be impossible. Oh wait, shit. No, this is just an example. If we take the maximums, then I think we can do that. Let's try it that way and see if we get their most optimal. I think my gut approach here is correct, where you basically take the highest net at every like step and you're good. But before we do any of that, let's get parsing. So for line and input dot lines, what does our line look like? So let's open this input day 13. So name. Yeah, I guess let's do that. So let's split by white space. We get name, and then we get a word here. We get a number, and then the last one is the thing. So line split white space, and it ends with a dot, doesn't it? Yeah. So we can say let line is line dot trim. Oh, let line equals line dot trim and matches by dot. And then this can be still to do. Like that. Okay, so white space here is the split by white space. Can I do, is this double-ended? So I can say next back. Okay, so this is, I don't know what to call this. Let's call it target. And then we can say white space, I don't even know what to, like, this is the, so Alice is like the source. Is gonna be white space dot next. What else do we have? So if we say, then we can skip one. Ooh. So white space dot next. Let loss gain is white space next. If this is equal, and this should be unwrap. If this is equal to loss, then it's gonna be, no, actually this is fine. So let's just do this, not even this, just this, and no if. So this is now loss or gain. Then we can grab the number, quantity is this, and then we can parse it into, I guess, like an I16, and then unwrap. I guess I32 is probably a little bit better. Then we can unwrap, and then we can say times loss gain equals loss. Then it's -1, otherwise it's just the 1. Oh, and this needs to be if. Great. What next? Yeah, white space needs to be mutable. I agree. That's basically everything, right? If I just debug source, quantity, and target. Nope. Then we cargo our bin day 13. It's not called SRC, it's called source. Then we run this and we get Alice 54 Bob, Alice 79 Carol. Okay, so we're not doing negative correctly. It's not called loss, it's lose. There, so now Alice 54 Bob. So Alice gains 54 for with Bob. And then Alice loses 79 with Carol. Okay. That seems to be correct. Now, how do we store this? I think just have a map. And then we just say map.insert, or I guess not insert, but entry over source dot or default insert, or no, push, like it's gonna be a vector of what? So I think it's gonna be target, and quantity. It's effectively like a weighted graph. Effectively. And then you need some types. So you're just a vec. Can a map is mutable? Yeah, that's fair. And then here we can just debug the map. God, I really dislike debug printing. Although that should not be. Why is that an option? Oh, target is an option. Okay, so yeah, I really don't like this super formatted debug printing. I wish it wasn't like this. But that's fine. So we get, like if we say Alice to Bob, and then we can see what Bob is to Alice. So I guess, let's try this. So let's say for target and QTY in map at Alice. Let's just debug. Honestly, no, let's make this be a hash map. Borrow moved value. Why are you moved? Go away. Fuck off. Okay, so now target is the same kind of thing. Actually, can I just do that? No, I cannot. Great. So target is a thing, but then we can say map at target at Alice. Then we can say target Alice. We can eprint line here. It's probably better. Eprint line Alice, and target is some quantity. So this is target and this is quantity. Helps to be able to type correctly. So Alice and Carol gets a really big negative score. Alice and Bob gets a really high positive score. Okay, let's do this, but for like for person. And then this is like, I don't know. We'll say V, but I feel like emotion or happiness, I guess, is probably a better word. Happiness. H. Okay, great. And then this is at P. And then this is going to be P. Consider removing, yes. No. Oh, you're already a reference. Yeah, those references aren't necessary. Okay, we run this. We say David and Alice. Okay, so actually, let's go this way. So Alice and Bob. Give 137. And so that's right. So that is, where is it? You could see Bob next to Alice. Wait. So this is Alice next to David. So who is David's number one? David's number one is Carol. Interesting. Let's try this. Let's take all of these, put them into a map, and see what we get. into a B tree map specifically. This does kind of imply that the values are unique though, so that's actually probably not great. Let's do a vector and then say quantity source target. Not source, but P. And then we'll say sorted dot sort. It can be unstable. And we can do by key. What? Yeah. And then x dot 0. And then this, no, not this. Then this is the, so that's annoying. Let's do for s in sorted. Let's actually just grab this. And do that. So the highest is Bob and Alice. Then the next highest is David and Carol. Then we get Bob and Carol. We get David and Alice. So literally, if we just do this in descending order, we get the correct pairings, right? If you seat Alice next to David, so Alice and David is like the second highest for Alice. Okay, so this is weird, I think. I think I have a good idea of how to implement this. The issue kind of comes in with like, what? I mean, I guess, I don't know. I don't know what I'm struggling with here. Basically, we just take the two, but like if you have Alice and Bob sitting next to each other and you have Carol and David sitting next to each other, then Carol and Bob have to sit next to each other, which is fine. But how do we like represent that is the issue that I'm struggling with. Let's see what it looks like in the actual data. This also seems maybe potentially fairly straightforward. Yeah, I guess the biggest thing that I'm struggling with is how do we represent this? So let's see. I would like to do that first of all, so that we get sorted in descending order. Although no, actually I take that back. Let's not do that. I really need to stop deleting that. Go away. This guy. Interestingly, these pairs are always like, we don't have anything that has like duplicate like quantity, like happiness score, which is interesting. I don't think I want to rely on that though. That feels a little bit too I guess overfit is kind of a word. But I would like a slightly better way of representing this. So I would like to say, basically we don't need to have both people represented. I think it's okay to do if P is less than target and do this. Meaning that we only ever get one instance of each of these. And it'll always be alphabetically sorted, but it doesn't really matter. No, I take that back. Instead of updating, instead of creating something like this, I untake that back. I think we're gonna stick with this. I think we just need to do some sort of implementation. So, what first? Basically, I think for each, let's do something bad, and then we can see if we can improve it. So let pairs. There's gonna be a hash map from stir, which is no, that doesn't even work. I was gonna say we take a name and then we end up doing option stir. It would work, but it would require a weird amount of like synchronization. I mean, these are almost like doubly linked lists. But like circular. This is weird. My brain cannot choose a data structure here. Why? You know what? I think this will work. It'll just be a little bit weird. Okay, we're gonna say while pairs.len is less than like map.len. I would also like to rename this to be happiness. We're gonna say sorted.pop. So this is the, what is this? We can unwrap here. This is gonna be quantity, wow, P and target. Which I guess at this point, this P and target naming is a little bit weird and kind of wrong. Borrow of moved value sorted. Yeah, okay, great. Okay, so we're gonna do this. And then what? So we're gonna say if let some pair is pairs.get P. If pair 0 is none, no. Match pair, and then if we get some none, we're gonna do something. Actually, if we get none, we're gonna do something. If we get none, some, we're gonna set the left side. And then if we get some, we're just gonna continue. Right, so this means that the happiest pair is already taken. Somehow, I don't think this should be possible. In fact, let's do I guess let's do pair. No, not pair, but P. Great. Okay, and then so for the case where we have none, we're gonna say, I mean, this really just shouldn't be possible, but it's fine. Let's do get mute. And then let's say, I guess the question is like, where do we default? Like, or which side do we set? And I feel like I'm overthinking this, to be honest. That's what's kind of driving me nuts. I feel like I'm massively overthinking this. Because like if we set Alice and Bob next to each other. Wait, does the siding even matter? I feel like it doesn't matter. Is there a case where we want to set a specific side? Like if we look back at this example, David is to the right of Alice, but if we set David to the left of Alice, it doesn't matter. Yeah, I think the order doesn't matter. Which means that would be even better. Oh, actually no, this is gonna be the same, but this is gonna be this. Which I guess literally doesn't even change anything. It's still gonna be, it's effectively the same thing as a tuple, just the two types are the same. But that's fine. So if we get, yeah, in fact, it's a little bit weird to be using an array here, but it's fine. Let's do unreachable. Let's just make this case illegal. So if we have nothing, then pair at 0 should become what? It's going to become target. And then we can say pair, no, pairs dot get. Oh, I can't get mute. I can't do this. We have to, but this cannot be mutable. This needs to be get and then pairs at pair at 0 is sum. Not pair, but p. And then here we're going to say pairs.entry of target dot or default. Fuck, we can't even just push. You know what? Let's just make these a vector. Purely so we can dot push. Then we're going to push p. No, it doesn't even need to be an option now. Okay, so if we get 0, if we get 1, this case is no longer possible. If we get 2, then we get that. Great. Why are you upset? You need to stir found an option. Yeah. Non-exhaustive. I don't care. This is unreachable. Cannot borrow data. Yeah, that's kind of what I was concerned about. You're gonna be okay with that? You're not gonna be okay with that. Cannot borrow data of that as mutable. Trait index mute is oh. Wait, why can't we just use that as mutable? Oh, because we need to mutate it here as well. Okay, no, that all makes sense. And then honestly, how does this differ if we already have 1? I don't think it does. And then do we need to do the same thing for target? I think we do. Also, wow, that's a massive deja vu moment. What the fuck? Yeah, so you're gonna be target. You're gonna be target, push P. Oh, I guess these lines are the same. And then we don't actually care about the quantity. And then if this is the case, then we can just return. No, not return. Continue. Right? Like, we don't want to continue on the rest of that, if that's the case. This is not going to work, I think. Line 33 had a none. Oop. This guy had a none. Also, we ran that in release mode, which I definitely don't want to do yet. Line 33 had a none. Really? Let's just, debug pairs. Also, wait, we're not even pushing it to pairs. So if that pair is not already in there, then we're gonna say basically we're gonna do this. And this continue probably shouldn't be here. And then, yeah, this debug needs to be by reference. That's fine. Okay, so we get Bob and Alice sit next to each other. Great, so that's a start. Then we get Carol and David, but they don't get inserted. Oh, because we don't log pairs at the end. So ultimately, we get David and Carol sit next to each other. Bob and Alice sit next to each other. But we don't ever get the association between Alice and Bob. Right, I think this is wrong. This should be... While pairs... This... And pairs dot iter... Or dot, I guess, dot values... Dot all... VLen equals 2. No, that's wrong. Wait. So every pair, I guess not. So if any is not 2, then we're going to continue looping, except not. Why is that wrong? Okay, that looks to be correct. Alice sits next to Bob and David. Carol sits next to David and Bob. Carol sits next to David and Bob. Alice, wait. Yeah, and then David sits next to Carol and Alice. And Bob sits next to Alice and Carol. So that is correct. Does this work on release? Entered unreachable code. So that's what, 64. That means that we've pushed too much. So there is a case here. We should probably check PV for P, whatever P is supposed to stand for, vector. I can't do this, I think. I'd be surprised if this works. It shouldn't work. Yeah. Basically, we can't set them next to each other if they already have 2 people, and we're not doing that check. But how do we do that check? I can't think of an actually good way to do this. So let's just say, I mean, we have pair. We already know that We know that this one is empty. We don't know that the target is empty. So we can do the target vector if, yeah, okay, let's do it here. If tv.len equals 2 is less than 2, then we do this. Less than 2, then we can do that. Great, you can be like that. And the continue goes here as well, because if we don't have that, then we're gonna check the next side. This feels like really bad code. I think we'll clean it up if it works. Entered unreachable code. Let's see what pair contains. George, Alice, and Mallory. Great, so it still pushed 3 items. Oh, I guess here we don't actually check that pairs is... No, but we know pairs has to be empty here, or P has to be empty here. Oh, but this one now is PV. Okay. Now we've got a seating arrangement here. That's cool. Yeah, this code is remarkably bad, but we'll fix it. We'll refactor this later. 4P in pairs. Let mut sum is I32. No, what? 0. Which I think defaults to an I32 anyways, yeah. Then we can say P here is the source. To like destinations, I guess. And then 4D in dests. And we're gonna say happiness at source at dest. That. And then if we here return sum. And these, I guess, are going to be an I32 now. We get 469. Let's confirm on this data that we get 330. I guess let's see if 469 is correct. That seems awfully low, I think. Let's clean up some of this logging. I just want to get a look at what the like this part specifically ends up being. Okay. I guess we'll try 469. Drum roll, please. That's not right. Too low. Okay, so I was right. Or not right, but my suspicion was correct. So, like we know, so David here is kind of spoken for, right? David sits next to Alice and George. That seems to be pretty well defined. I debug pairs. Is that what we end up with? So David sits next to Alice and George. So there's two cases here. Either the thinking is correct and the implementation is wrong, or the thinking is wrong and the implementation is correct. Or, I mean, I guess there's the other case of the thinking is wrong and the implementation is wrong. But if the thinking is wrong, then it doesn't really matter. So Bob sits next to George and Alice sits next to Bob. That is an issue. Right, like we just closed the loop here. So Alice is with David and Bob is with George. So that's a circle of like 4 people. Right, so Alice is with David and Bob. Bob is with George and George is with David. So we just have a circle of literally 4 people. Which obviously doesn't work because we need a circle of all of the people. How many permutations do we have? So we've got 8 people. I don't think I have factorial, yeah. 40,000. Right? That's the number of permutations around the circle we have, right? Like, why can't we just calculate them all and then grab the max? That seems reasonable. Let's do that. I'm going to do this. So we end up with that. We can remove this sum and restore this to do. So we end up with this. Then let's say what? So God, I wish we had generators. This would be so much nicer if we had generators. Fuck it. Let's create a function. Permute happiness keys to, or I guess collect. Names is a vec of stirs, and it return, actually this can be really a slice of stirs, and it's going to return a vector of, it's not, are these permutations? I don't think these are permutations. I don't know, are these permutations? Yes, this is a permutation. Technically, these could be arrays of stirs. I'm going to do vec of stir just because it's a little bit easier to work with. I'm not sure if it matters, though. Or, I guess it does matter because it adds, like, allocations, but it's fine. Yeah, it's fine. How do we do this? So for x in, or for name in names at 0, we're gonna say, and I guess the other thing is, sorry, I know I keep interrupting myself, but I guess the other thing here is, it's not even necessarily every single permutation, because if you get like A, B, C as the permutation, this is equivalent to B, C, A, because it's a circle. But I don't really know how to implement it that way, so we're not going to bother. We're going to say permute names from 1 if names is empty, then we're just going to return vec new. This is wrong. For name and names. Why is my brain not braining? What the fuck? It's not even name and names. It's like names to vec dot remove. This shouldn't be so complicated. Why is my brain not braining? Swap remove. Names dot index position name. Like, this is obviously a very inefficient way to do this, but also swap remove does that. Oh, I guess we have the I. And then IADX becomes I. Great. So that is technically not permutation still. Fuck. What is the thing? So now I need to say permute returns a bunch of vectors. And then I need to like P dot for each P dot iter mute. Like this is obviously really bad. Like really, really, really bad. Type annotations needed. Oh. Then you can be P or out. And this, I guess, still needs to be a vector of stir. Or wait, sorry. No. Yes. What do you mean type annotations needed? It knows what P is. Oh, this needs to be as or copied. I don't know why you think an annotation needs to be here. You do need to definitely be tick A. Can I elide this? No. That's okay. So you're tick A. You need to be to, oh, that's why you think you need that. This needs to be into iter. Yeah, you're no longer mutable. You need to be mutable. You need to be mutable. Like that. So this really horrible permutations algorithm should potentially work. Except it very much does not. Oh, God damn it. Okay. If names is empty, return an empty vector. Okay. For I and name, or I, wait. For every name, allocate the name. remove the current name, then do permutations over the rest of the names. Then for everything that we get in the permutations, I mean, this should work. So it's literally always empty. Why is it always empty? Oh, we don't want to do if names is empty. We want to do if names.len. Yeah, is less than, we go to 1. Then we're going to say, or is equal to 1. Then we're going to say vec names 0. Or no, we're just going to say names.toVec. And then a vector of that. Great. So foo bar baz can do foo baz bar baz, bar foo baz foo, baz foo bar foo. That is correct. Right? Yeah, that should be correct. And there's 6. Yep. Okay. Now if we do this, we get the 4 orientations. And these aren't necessarily unique orientations at all. Actually, I'm just curious. Based on this by itself, I mean, it takes 34 milliseconds to do that, but that's not... This is the other thing. Like, it's slow as fuck. And in fairness, that is potentially partially due to the printing. Yeah, that's quite a bit better. If we remove that printing and remove that printing, this should be quite a bit better. Yeah, but it's still almost 300 milliseconds, so it's not great. Part of that is to do with all of this allocation and stuff in here. This is obviously really poorly done. It should not be this. It should not be like this, but it is. Or that's how I've done it. So we'll clean it up whenever we get to the optimization stage, but for now this is fine. One thing I will do is replace this with a fuck, I was gonna say replace this with an iterator, but that's too much of a pain to do right now. Purely because of this line. If we weren't doing this, then it'd be pretty easy to turn this just into an iterator that we return. But if we're gonna have a separate iterator, then we need to return a box over an iterator, which I guess is fine. Let's just do that. This is gonna be return impl iterator item is, what are you complaining about? Go away. Item is that. And then here we just say names.iter.enumerate.map. Can you like go the fuck away? Why are you suddenly complaining about everything? Stop. What are you fucking complaining about? Entered unreachable code. I don't care. Maybe it's just really unhappy with this current state of things. Stop fucking... God, that's so annoying. you go. Fuck off. You go away. Fuck the fuck off. This is not even a map. This is a flat map. And then this is gonna be p.into_iter dot map p to be this, and out goes away. This permute becomes this, and this is no longer an into_iter. Like that. Mismatch types expected vec. Excuse me, vec of vec. Right. So this needs to be box new. This needs to be a box new standard iter once. And now the thing is wrong, but I need to say this is a box over din iterator item. Actually, can I just do din iterator? No, I need the associated type. So item equals vec tick a stir. And I'm missing the that. The function blah 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 does not exist because of reasons like what? But it shouldn't need to be sized, right? Like that's the entire point of the box. Am I stupid? Or, box over din iterator. Okay, maybe I am being stupid. Who knows? Lifetime may not live long enough. Fuck the fuck off. You're a tick B. But I can't wait. To declare plus tick B. Plus is used to construct a trait object. What? Okay. Cannot return value referencing local value, but local. Shit, you're right. Okay. Yeah, no, that's totally right. We're gonna pretend like none of this ever happened. Yes, I know. Oh my god, stop. Is there like a... How do I have Rust Analyzer? Cargo install Rust. Wait, Rust up update. Oh, I probably shouldn't do this. Let's do it. Then we'll leave this running in the background. No, okay. This is gonna be so annoying. Like, I just want to undo. If I do, yeah, I literally can't even. I have to dismiss this every time. What if I did LSP off? Oh wait, LSP stop. I do have a lot of Rust tooling and stuff installed, so this might take a minute. Okay, so we have that. I can't run it or do anything like that until we have our thing back, but that's fine. We can, oh, I guess Rust Analyzer's back. We can, what do we do? So what are we gonna do here? So this is gonna be into iter.map Then this takes the sequence of names. And this says let mut sum equals 0 for n in names. And really we could say names.zip names1 zip or names1 dot iter dot chain standard iter once names 0. This should do a thing. Expected one star to be an iterator that yields that. This should be like copied. And this should be copied. Just because I want to see if this will work. No, cargo R. Obviously we get a bunch of warnings or whatever. Oh, wait, because we never run through this iterator. Max. Why does that never happen? I'm confused. Also, this can go away. Oh, this is still broken. Vec of names to vec. And this is going to be names.len is less than or equal to 1. Great. So now, if I just say standard process exit 1, and then we debug names. I really hate that debug by default like takes ownership. So names is Alice, David, Bob, Carol. Sorry, Alice, David, Carol, Bob. We get Alice and David. We get David and Carol. We get Carol and Bob. And we get Bob and Atlas. So this actually does the looping. That's perfect. So this is going to be sum plus equals happiness at AB and sum plus equals happiness at BA. Then we just max and then we can just happiness. And sure, Clippy will do what you want. 330. So that's correct. What do we get if we run it on the real input? We get 664. So we had 469 before and that was too low. 664. Let's actually write that down. So 469 too low. And then 664 is correct. Okay. Finally, it only took us a fucking hour to do that, but we got it. Next part. In all the commotion, you realize that you forgot to seat yourself. Yeah, fuck. You're pretty apathetic towards the whole thing, and your happiness wouldn't really go up or down regardless of who you sit next to. You assume everyone else would be just as ambivalent, but sitting next to you too. Sounds like you're a real life of the party. We are. So you add yourself to the list and give all happiness relationships that involve you a total score of 0. That is equivalent to not handling the loop. Oop. So this weird like chain business, that is the equivalent of not doing that. Right? So let's grab part 2. I think I'm right in that. This is an I-32. This one is What was our value? 664. And then this can go away because I don't actually give a shit about any of this anymore. And then I think this should be the same thing. So if we run this on the example input, we get... This is a bit annoying. If we have debug assertions... Actually, yeah, if we have debug assertions, let's just do debug. So part 1 is 330, part 2 is 286. Oh, it doesn't give the example. Wait, what is the total change in happiness for the optimal seating arrangement? Okay, total change in happiness is the word from before. I really wish that he gave the example for, or the value for the example to actually check that this is correct. You're pretty apathetic towards the whole thing, and your happiness wouldn't really go up or down. So you guys yourself to the list. Give all happiness relations that involve you a score of 0. I think that should that should be the same as just not handling the loop. Fuck it. You know what? Let's just try it. 640. Wow. So participation makes it significantly less happy, the party. 640. Yep. So just us showing up drops the happiness of the whole party down by 24 points. So guess that's just us. Okay. So I'm going to remove this solution. It might be faster, but it's not. It doesn't work in my brain. So let's add everything and say day 13. And then let's do a little bit of timing. So cargo be release. I don't care about all of that. And you need to know and I guess we could just like hyperfine too. Hyperfine and just run it a bunch of times. So we're getting 39 milliseconds, which isn't like horrible. It's not great. Like, I think, honestly, this is a big thing. And that's pretty much it. Everything else is fairly cheap. So, removing the allocation here would be super, super helpful. But I don't see a way to do that. Like, we need to have the names minus some number of indices. And we are reserving here, so we are at least somewhat conscious about how much space we need here. I mean, technically, we would end up using a lot more memory, but if we said names by names, or names length squared, then we're not too far off of the factorial. That's wrong. It's still pretty far off. And I don't think it's worth trying to like write an actual factorial to get the size. Yeah. Yeah, okay, I think let's just leave this as is. It's actually ultimately, I think, the same thing to just push this to the end because the order doesn't matter. So if I run this like this, we saved maybe a millisecond, maybe, potentially. It's not certain that we did, purely because like it could just be noise, but I guess this works. Okay. That's good enough. Let's do, let's just append that. We can go ahead and push that. Then let's take like a 5-minute break and we'll be back and do bay 14. So be right back. Okay, let's get back to it. So, day 14. Let's get into it. Before we read any of that, let's set up our environment. So let's copy template to day 14. Actually, I want to update this template a little bit. Let's do if config debug assertions. Then we do this. Otherwise, what do we want to do if we're in debug assertion? So we can print line, just part 1. And then part 2. Part 1 of file and part 2 of file. Okay, and then we can I guess that's pretty much it. Is there anything else to like add here? Not really. I almost want to just throw a little bit of color in here. But do I remember how to do that off the top of my head? Not really. 033. But I don't know. I don't know how you do octal in Rust. Man ASCII. So 033 here is, oh, it's escape. So it's 27. I'm correct about that. And then what, 31 semicolon M? Brackets? There's a semicolon there. Do I not know? I don't remember how to do ASCII or ANSI code. ANSI color code. The table. Okay, sure. I usually just, that's 0. Oh, it's semicolon before. Does that 0? Is that the 0 required? Am I stupid? I'm being stupid. This needs to be dashi. Yeah. Okay. Pretend like you guys did not see that. Okay, we're gonna do green. So 32 M, and then we'll add blue, which is no yellow, of course. 33 M, like that, and then we have to reset. Okay, now we'll copy the template. Okay, and then source, no, input day 14.txt. And this is going to be day 14 input. Okay. And then we don't have an example. Well, we do, but it's in the, no, it's in the correct format. Then we have input, day 14 example.txt is this guy. Okay. And then day 14. Now let's do some reading. This year's the Reindeer Olympics. Like right now. Reindeer can fly at high speeds, but must rest occasionally to recover their energy. Santa would like to know which of his reindeer is fastest, and so he has them race. Reindeer can only either be flying, always at their top speed, or resting, and always spend whole seconds in either state. For example, suppose you have the following reindeer. Comet can fly for 14 kilometers a second for 10 seconds, but then must rest for 127 seconds. Dancer can fly 16 kilometers a second for 11 seconds, but then must rest for 162 seconds. After 1 second, Comet has gone 14 kilometers, while Dancer has gone 16 kilometers. After 10 seconds, blah, blah, blah. On the 12th second, both reindeer are resting. They continue to rest until the 138th second. Okay, great. In this example, after the 1000th second, both reindeer are resting, and Comet is in the lead at 100 that number of kilometers. So in this situation, Comet would win. Given your descriptions of each reindeer, after exactly 2,503 seconds, what distance has the winner reindeer traveled? Okay, so let's parse this. So we're gonna have, we need to add day 14 in the TOML. No, source day 14, great. So we're gonna say input.lines. Let's create a map. And I guess we can just do this. And this is going to be line dot what? So it's going to be line, I mean, really, we can just split again. It's kind of boring to just always use split white space, but that seems to be the best. So white space is this. White space, next, unwrap. White space, nth, does nth consume? I think it does. No, it's mutable. Okay. So nth is gonna be, if I do input, nope, if I do input day 14 ex.txt, so 0, 1, 2, and note 0 here, 0 starts there because we've already consumed this first item. So nth is at 2 is speed, and then finally we have rest. Oh no, this is duration. It is going to be 0, 1, 2. And these can be like U32. And then rest, and then, yeah, the rest is going to be 0, 1, 2. Actually, we can do rest is nth back 2. And then we say name, speed, duration, rest. And that can just be 2, but that's fine. And then let's just debug map and keep our to do here. White space here needs to be mutable, of course. Hash map needs to be imported. And then what else? Expected hash map, right? We need to .collect. Not that. Day 14, like so. We get a parse error. That's not great. Maybe nth is wrong? Which line does it fail on? It fails on 11. Oh, which is this one. Yeah, nth back 2 should give it... Oh, no, it's nth back 1. Yeah, so comment 14, 10, 127. The answer is 16, 11, 162. Okay, that is pretty simple. Now let's actually see what distances they go. So, I mean, honestly, this really doesn't even need to be a map. In here, we can figure out how much they need. So, it's after... It's kind of annoying that this is 2503, but this is 1000. Let's say let duration... Const duration is a U size is... If config debug assertions, then we're going to say 1000. Otherwise, we're going to say 2503. And that's uppercase. So let seconds is 0. While seconds is less than duration, we do this. So if let seconds left equals duration minus seconds. If well, okay, wait. So this is basically we're gonna say let mut resting is false, right? So we don't start off resting, and we also need let mut distance 0. If we're resting, then we're going to say we're no longer resting, and we're going to move forward. Yeah, so let time is seconds, no, duration dot min seconds left. So we're either going to move for however long we can, or we're going to move until we're out of time. And I guess just to keep things simple, let's make everything a U size. And then with this time, distance is going to be speed times time. And then seconds is going to increase by time. So we wake up, or we stop resting, whatever. Then for however much time we have left, we don't even need this resting thing. Okay, so we move until we're out of time, or we run out of ability to run. And then we can say if seconds is less than duration. Basically, we're going to do this part again. Then we're going to if seconds is less than duration, then we're going to rest. And then here we can return distance. Distance. And then we can say max. And then we end up with this. And seconds is mutable. And we get 1120, which is correct. Okay, now let's run this with release. We get 2660, which is correct. Beautiful. Seeing how reindeer move in bursts, Santa decides he's not pleased with the old scoring system. Instead, at the end of each second, he awards 1 point to the reindeer currently in the lead. Hey, thank you for the bit. Seeing how Santa decides he's not pleased with the scoring system, instead at the end of each second, he awards 1 point to the reindeer currently in the lead. If there are multiple reindeer tied for the lead, they each get 1 point. He keeps the traditional 2503 second time limit. Of course, as doing otherwise would be entirely ridiculous, obviously. Given the example reindeer from above, that. Okay, so we do kind of need to be second by second versus what we did before. Right? I don't see a different way to do this. I think we do need to be second by second. So let's do it that way. Name here literally doesn't matter, but I'm going to keep parsing it. Okay, part 2. Also, you can just be distance, which is a U size. And you are a U size. And you are unwrap. I guess there. Okay, input. Then what? So this distance parsing needs to end up like this. You know what's interesting is we could just have this return a basically end up having distances be a vector of U size by, what is this? 2503. Right, so we return a vector which contains the position of every, or of the individual reindeer for every second. And then afterwards, we look over them and we see which one was the biggest for most of the time. Does that make any sense? That's simpler, I think. But I think it adds unnecessary complexity on the other side of that, which is like actually figuring out which number is in the lead. No, you know what? Let's do this. Because arrays are a little bit annoying to deal with, we'll just make this be a vector. But with the understanding that it's effectively 1 point per second. So it's a bit weird. What do we do here? So, I mean, we could literally just walk every second and add a distance, or add a distance. Keep track of whether the reindeer is at rest. Yeah, I guess that works. So like you go away, you go away. Let distances is a vec new. Although, like, honestly, at this point, I don't know. It feels weird because at this point we're just overcomplicating it. Yeah, let's do the initial way of having a vec of speed, duration, and the rest. So this is speed, duration, rest. And then 4x in duration. Yeah. In 0 to duration. We're going to say we need some way of keeping track of the state. So let mut state is, or I get, it's going to be effectively distances dot map dot collect. We're going to basically ignore this value and we're going to use default, and then we're going to just have a struct reindeer, which has rest time, which is a usize, which is the amount of seconds that it has left resting. We're going to have the move time, which is the amount of seconds it has left moving. This is a little bit weird because it's one or the other, but that's fine. Actually, no, we'll say time left resting is a bool. No, we'll say moving is a bool. Just so we can derive default. And the default here is going to be 0. Default here is going to be true or false. So we can update that accordingly. That sounds fine. For every I and reindeer and stats in distances zip with state dot iter mute dot enumerate. And state here is not known, right? This is a vector of reindeer. And semicolon, of course. Great. So now stats should be this tuple above, which I guess speed, duration, rest. And then reindeer is a mutable reference to the state. And then I here is, I guess, unnecessary. To be fair. No, we still want the I. We're going to use that to track the max. And then here we'll say let mute count is a vec of usize is distances dot iter dot map to 0. Yeah. Okay. That's fine. And then what do we do in here? So here we're gonna say if reindeer dot moving then we're gonna say, but this also needs distance. Reindeer dot distance plus equals speed. And then we're going to say reindeer dot time left minus equals 1. So if reindeer dot time left is 0, then we're going to say reindeer dot moving equals not reindeer dot moving. So we switch from moving to rest or backward or vice versa. And then if reindeer moving now. Then we're gonna say reindeer.time left is, if we're moving, then it's gonna be duration. Otherwise, it's gonna be rest. And it wants to dereference those, but we can do that here. Or I guess here probably. Yeah. And reindeer. And then I guess here we do that. Like this feels really sketchy, but guess let's find out. Yeah, you can be debugged. And yeah, count isn't used yet. That's fine. Also, our logging here seems to be so incredibly fucked. That should be fine though, right? Is it not 2.7? Oh no, that's decimal. It's 1B. There we go. Look at that. Beautiful colors. I guess let's also update the, not that, but the template. That. Okay. Now what? Yeah, so this, oh, attempted to subtract the overflow. Mine, line 60. This guy. So we get 108 and 960, which is close. What needs to happen here? There we go. So we get 1120 and 1056, which is the same numbers we got before. Except that now we can say we can say state.iter.map r dot distance dot enumerate dot max by max by key, where key is I and distance. We're gonna max by distance, and then we get the I, which here is going to be count at I plus equals 1. And this is technically an option, but it's going to be this. No, it's not necessarily a single maximum. That's really annoying. Yeah, we have to collect into a vec. And then we're going to say x.sort by key takes in the tuple, and gives us this. And it can be sort unstable. And then now, this next part is a little bit annoying because we could have a vector which is effectively like 2, 2, 2, 3, and we basically need to say no. It can be like this. Or I guess more accurately like that. Oh, and this is sort ascending. So this needs to be standard, comp, ord, or ordering, reverse D. What? How do you use this? Oh, it needs to be for an actual comparison. Okay, fine. Sort unstable by A, B, AD dot comp, BD. I guess it's just that. Okay, so x dot into iter dot filter. Okay. Yeah. No. Why is this so confusing? What the fuck am I doing? Go away. All of this goes away. None of this is useful. You go away. Okay. We're going to map to the distance. We're going to enumerate. We're going to filter. We don't care about the I, but the distance. Max is going to be state iter. Basically this again. Dot max. So this is the maximum distance. Then we're going to say filter where D is max. There we go. And then we can... D here is that. And max is on round. Great. Take all the max stuff. Then we're going to say for each I, distance doesn't matter. Then we're going to say count at I plus equals 1. I don't know why I was thinking that to be so complicated. Great. Not yet implemented. Right. We need to debug count, basically. And I guess we can keep debugging state. So 689 is the max. How many points is, wait. So Dancer has accumulated 689 points. Yeah, okay, great. So count dot max. Dot unwrap. $689. And then on release, we get 2660. Which is not correct. It's too high. Of course it is. And I guess we don't need this. Which means we don't need this. So I think our issue is in what we do for each step. Right, so after our first second, so like during our first second, time left is 0, so we set moving to true, we set time left to be duration. If the reindeer is moving, yeah, so if the reindeer is moving, which it is, then we increase the distance, and we remove time left. Then we keep going for a little bit, and then at a certain point, time left becomes 0, moving becomes false, time left becomes rest, and then we just decrement that over and over again. So why is that wrong? Also, why did that not debug? Oh, am I being fucking stupid? Yeah, I just did it stupid. I mean, like, in reality, we should probably do like this. Or even part 1. Part 2. What does that error message look like? It's not really super obvious, but it's fine. 12560 is definitely a smaller number. And it's the correct smaller number. Hell yeah. Okay, cool. So 12560. Wait. No, 1256. No 0 at the end. Great. You go away, you go away, you go away. How long does this take? Cargo be not day 13. Oh. It's really, really fast. Half a millisecond. Okay, I don't really think that we can optimize this too much. It's a fairly decent solution. We don't do a whole lot. I guess that can be an underscore. Bam, optimization. Ooh, look, that can be inline. Bam, optimization. I like how part 1 is literally a one-line function. Part 2 is not, but it's just great. Yeah, so we're at 500 milliseconds. I'm not gonna bother optimizing this, I think. Day 14. We're gonna push that. And that gets put into the repository right here. And that is going to be all for today. So thank you, everybody who's watching, and I will see you next time.